Hello everyone. What we are going to focus on in this video is angle of elevation and depression, right? So let's say that you're on a level ground that looks like this, right? And you're standing at a point which we call a point A, right? And you're looking at a building that is 100 meters away. So 100 meters away. So let's say the building is here. Right? This is the building you're looking at. But when you look on top of the building, you saw a flag. Right? It's a flagpole. Flag looks something like this. Right? And your angle of elevation to the foot of the flag, which is this line here, is 30 degrees. Right? And your angle of elevation from point A to the top of the flag, that point is 40 degrees. Right? So that angle here is 40 degrees. And then somebody asks you to determine the height of the flag. So they wanted to determine the height of the flag, right? Now, how would you go about determining the height of this flag? What you could do is to put some more letters on the diagram. You know that this would be a representation of the ground. And where the ground and the building meets, they create a 90 degrees, right? We also know that we could say that at this point, this is B, where the foot of the flag is, that's point C, and where the top of the flag is, that's point D. Right? What that does, it helps us to identify at least two triangles. So now, if you notice, you would have two triangles, A, B, C, and also a triangle A, B, D. Right? Now, remember that they want us to determine the height of the flag. So the height of the flag here would be CD. Right? CD, right? So they want us to determine that height. But based on the information that we have, what could we use this information to determine? We have an angle which is 30 degrees that is opposite to the building, right? So this side here is the opposite. And we have this angle that is adjacent to this side. And we know the length from A to B, right? Know that that is 100. Now with this information, we could determine the height of the building. And in this case, the height of the building is going to be BC. Right? So we could determine the height of the building, which is BC in this case. We could also determine the height of the building plus the height of the flag. That would be the height of so we could determine the height of BD. Right? Now if you notice, if we determine the height of BC and determine the height of BD, then we can go ahead and find the height of the flag, right, which is CD. Because if you notice here, the height of the building plus the height of the flag would give you the height of this entire BD here, right? Now, we know that opposite over the adjacent, if this would be the adjacent side, according to the angle, the ratio opposite over adjacent is associated with tangent of an angle. So we know that tan x is equal to opposite over the adjacent. Right? What is x in this case? In this case, we are finding BC. So we are taking into consideration the triangle A, B, C. So when you want to find BC, you have to think about the triangle A, B, C, right? Because that's where the 30 degrees falls. So if you are considering triangle ABC, we know that tan of 30 degrees, which is this angle here, is equal to the opposite length, which we don't know, which we call BC, so that's BC, all over the adjacent length, which is 100 meter here. Now, to find what BC is, we can multiply both sides by 100. So multiply both sides by 100, we left back with BC is equal to 100 multiplied by tan of 30 degrees. Right? So you put this on your calculator, which is 100 times tan 30, BC would equal to approximately 57.7 meter. Right? That's correct to one decimal place. So now we have this distance here, which is from here to here. So we need this distance, which is BD. But if we need to find BD, that is associated with the triangle ABD, which has to do with 40 degrees, right? So we know that if we take into consideration the triangle ABD, then tan of 40 degrees, which is this angle here, is equal to the opposite length, which we don't know, is equal to the opposite length, which we don't know, which is BD in this case, all over the adjacent length, which is 100 meter. Right? Now you want to find what BD is, you need to multiply both sides by 100. So if you multiply this side by 100, 100 going to cancel out 100, right? So you're left back with BD is equal to 100 times tan 40 degrees. Right? So BD is equal to, and all you need to do is to put this on your calculator. So that's just 100 times tangent of 40 degrees, and that is equal to approximately 83.9 meters, correct to 1 dp. But remember, they didn't ask you to find BD nor BC. They wanted to find the height of the flag, which is CD. So now, if you closely look, we could formulate an equation to find CD, right? If you note here, CD is equal to this length here, which is BD, minus the shorter length here, which is the height of the building, which is BC. Right? So therefore, BD, what is BD? We just found that out to be 83.9, so that is 83.9 meter minus BC, and BC is 57.7, so that is 57.7 meter, right? Which is equal to, put that on your calculator, so you have 83.9 minus 57.7, and that is equal to 26.2 meters. So therefore, the height of the flag is 26.2 meters. Let's say that you are now standing on a building, right? So you have a building here. And you know the building is on a level ground. So let me just draw that level ground. So you're standing on top of a building. And you know that the height of the building is, say, 90 meters. So you're standing on the top of a building that is 90 meters tall, and your height is 5 meters, right? And you saw 2 cars parked on the ground, right? One parked at point A, which is here, and you saw another car parked at point B, which is here, right? But your angle of depression to point A is 19 degrees. The angle of depression to point A, that means you need a horizontal line of sight. So your angle of depression to point A is 19 degrees, right? And your angle of depression to point B is 25 degrees. So now the angle of depression to point B is 25 degrees, right? So you know that this line would be your horizontal. Right? So this is your horizontal line of sight. So your angle of depression when you look down at the car at point A, that's 19 degrees. And when you look down at the car at point B, that's 25 degrees. Right? And they ask you to calculate the distance from point A to B. So they want you to calculate this distance here. From A to B, so they want you to calculate the distance AB. So they want you to calculate that distance. How would you use this information to calculate the distance from the distance of AB? One thing that you could do, you could try to put some more letters on the diagram, right? So you know that the ground and the building, which is this part here, which is the building, that is always meet at 90 degrees. So you could put a point here to say, okay, this is point C then. And where you're looking from, that is just point D here, right? So which gives you enough information to identify different triangles, right? So one triangle that we can identify is ACD. Another triangle is BCD. Now we know this length, right? This is just 90 meters plus 5 more meters. So the entire length here, which is DC, that's just 95 meters, right? Now, if we know this angle or this angle, it means that we could calculate some lengths down here, right? So how would you know which angle to put here? And which angle to put here? One fact that you can draw on is that the angle of depression is equal to the angle of elevation. So here we have a depression coming down, but here from this point we have an elevation going up. So we know that the angle of the pressure is equal to the angle of elevation. So this angle here is 19, so it means that this one is going to be 19 as well. So this is going to be 19 degrees. Another perspective that you could use is that your horizontal line of sight is always parallel to the ground. Now where you have parallel lines, you could view these as transversal, touching both parallel lines, right? So where you have a transversal and cutting a parallel lines, you have angles are formed, and one of them are alternate angles, are what you would call Z angles. And one thing we know about those angles are Z angles are always equal, or alternate angles are always equal. So here, if you follow this line here, you follow this line and you come this way and then you come down, you get this Z here. So that means this, all of this angle is 25 degrees. So it means that this angle is 25 degrees as well. And what you can do to always know where to put the angle, the closer the lines approach the building, the larger the angle, right? So that's a point to know. So now we want to find AB. It means that we can find the length. We can find this length, which is CB. We can find that length because we have enough information to calculate the length CB, and we also can find the length of AC. We have enough information to calculate that, right? So here, this part is just BC, so we can calculate that length. And this line here, that's just AC. So we can calculate that length as well. Why would I calculate these lengths? Clearly from the diagram, you must be able to identify that AB, which is this length here, is equal to AC minus BC. Right? And remember that they asked us to calculate the length of AC. That's the distance between where the two cars park, right? So from this diagram we can clearly see that. So now we can go ahead and use the trig ratio to calculate the distance of BC and AC. Now, so let's do that. We know that here, if you consider the triangle BCD, considering triangle BCD, identify that BCD, we have an angle which is 25 degrees, right? And this side is opposite to that angle, so we know that this is opposite, this side is opposite to the angle. And this length is the adjacent length. Adjacent length. So that's basically the adjacent length we want to find, which is BC in this case. So we know that this ratio is associated with tangent. So we can therefore say that tangent of 25 degrees is equal to the opposite length. And what is the opposite length? The opposite length here is 90 plus 5, which is 95. So that's 95 meters over BC. Right? Now you want to find BC, multiply both sides by BC. So here, BC is equal to, if we multiply both sides by BC, BC times tan 25 degrees is equal to 95. Right? Then we divide both sides by tan 25 to get BC by itself. So BC is equal to 95 meters divided by tangent of 25 degrees. So BC is equal to, and you put that on your calculator, right? So that's going to be 95 divided by tangent of 25 degrees. And that is approximately 204 4 meters to the nearest whole number, right? 204 meters to the nearest whole number. So we know this distance here. So we know that BC here, which is this distance, is 204 meters, right? So we need this large distance here, which is AC. So now I'm going to go ahead and find that. So now, same idea, we have an angle, and all of this side is opposite, and we know that length, so therefore, tan of 19 degrees is equal to the opposite length, which is 95 meters, over the adjacent side, which is AC. Again, if you multiply both sides by AC and then divide both sides by 19 degrees, AC is going to equal to 95 meters divided by tan of 19 degrees. So AC is equal to 95 divided by tan of 19 degrees, and that gives us a distance of approximately 276 meters to the nearest whole number. So now we know that this length here is 276 meters, right? So therefore we can go ahead and find the value of AB, which is the distance between both cars, where both cars park, right? So we know that AB is equal to AC minus BC. So therefore, AB is equal to AC. What is AC? 276, right? So that's just 276 minus BC, which is 204. So that's just 204. So AB is equal to 6 minus 4, that leaves us with 2, right? 7 minus 0, that leaves us with 7. And 2 minus 2 leaves us with nothing. So the distance of AB here is 72 meters, right? So this distance here would be 72 meters. And that is how you would use this information to calculate the distance between the two cars, where the two cars park, right? Alright, what we are going to do now, we are going to look at some worded problems, right? From a coastal lookout point P, 100 meters above sea, a sailor sighted two boats A and B in the same direction. The angle of depression of the two boats are 15 degrees and 23 degrees respectively. Calculate the distance between the two boats. Now the first thing you would need to do is to make a representation of this question, right? So we know we could locate point P. So let's say point P is here. We know that from a coastal point, point P, 100 meters above sea. So let's say that use a straight line to present where the sea would be. So let's say that this is the sea. We have some water down here, so, right? So 100 meters from this point here. P is 100 meters from where the sea is, right? Above the sea. So we know also we know that the sailor sighted two boats A and B, right? So from this point he sights two boats A and B in the same direction, right? So let's say that this is one boat. This is where one boat is. This is where another boat is. So we know inside two boats A and B, right? In the same direction. The angle of depression of the two boats are 15 degrees and 23 degrees respectively. So we know that point A is here and point B is here. So that's both A, both B, right? From this point P, right, he sights the both A and he sight both B, right? They also give us the angle. They say that the angle of depression. So if we have an angle of depression, what do we need? We need a horizontal line of sight first. So this is our right? So we need that. We know that one of the both is 15 degrees. So we know this is 15 degrees. Know that this has to be the 23 degrees, right? Right? So we also know that angle of depression is equal to angle of elevation. So this is 15 degrees. So this is what? 23 degrees. We know that they want us to determine the distance between both boats, which is this distance here. And let's say that distance is just AB. Right? So we could put a point here, right? To just complete a triangle. Let's call this S. Point S, since it's C we're talking about. So now, we want this distance. How would you go about calculating this distance? We can calculate the distance SB, right? So we could calculate this distance, which is SB. We could calculate that distance. We could also calculate the distance SA. And from calculating these two distances, it's clear that we can find AB, right? What is AB? We know that AB is going to equal to AS minus BS, right? So if you have this distance and you subtract this distance from it, you get this distance. Because this distance plus this distance equals this distance. Make sense? So we know that here when you're focusing on triangle SBP, then that is associated with this 23 degrees angle. When we are associating ourselves with the triangle SAP, that is associated with 15 degrees. So we know that this 23 degrees, that this side is opposite to it. That means this side is adjacent where SB is, that's the adjacent. And again, the tangent ratio we're going to use. So we can therefore say, considering triangle, so we know we are looking at triangle P, SB, right? PSB, which is this triangle here, which has a 23 degrees angle. So we know that tan of 23 degrees is equal to the opposite length, which is 100 meters, over the adjacent length, which is SB in this case. Right? And doesn't matter if you say SB or BS, same thing. So now we want to find SB, right? So we're going to multiply both sides by SB, so we know that SB times tan of 23 degrees is equal to 100 meters. Because SB is going to cancel out here, right? So now we need to divide both sides by tan 23 and divide this side by tan 23. So we know tan 23 cancel out tan 23. Then that means SB is equal to 100 divided by tangent of 23 degrees. Right? And you just put that on your calculator and you find what SB is. So if we put that on our calculator, we know that that's going to be 100 divided by tangent of 23 degrees and that is equal to a length of approximately 236. No, let's use one decimal place. 235.6 carried to 1 dp, right? And that's meters there. So we know that this little distance here is now 235.6 meter, right? So now we need this distance, this larger distance, which is AS, right? Now we're going to calculate the value of AS. But when we are calculating the value of AS, we have to take into consideration the triangle PSA, so which is PSA. If we are focusing on PSA, there's only one angle in PSA, which is this 15 degrees here that we know, and that is opposite to this side here, which is 100. So we know that tan of 15 degrees is equal to the opposite side, which is 100, all of that divided by SA, right, or AS, doesn't matter, right? Now we want to find AS, multiply both sides by AS, multiply this side by AS, also multiply this side by AS. AS cancel out AS. What we left back with is AS times tangent of 15 degrees is equal to 100. Right? So we know what we left back with is AS times tangent of 15 degrees is equal to 100. So now we need to divide both sides by tan 15. Divide this side by tan 15. Tan 15 cancel out tan 15 degrees. So left back with AS is equal to 100 divided by tangent of 15 degrees. So AS is equal to, you put that on your calculator, 373.2 meters, right? That's round off to one decimal place there. So we know this entire length here, which is 373.2 meters. And clearly from the diagram, you can see that SB plus AB has to equal to SA. Therefore, AB is equal to AS minus SB. That's where I get this little formula from. Now we can go ahead and calculate the distance between both boats, because remember they say calculate the distance between the two boats. So now this formula gives us the distance between the two boats. So now we know that AB is equal to AS. What is AS? AS is just 373.2 minus BS, right? BS is what? 235.6. If you put this on your calculator, you will get an answer of 137.6 meters. Therefore, the distance between the two boats is equal to 137.6 meters. Alright, so let's look at another worded problem. A surveyor stands 100 meters from the base of a tower on which an aerial stands. He measures the angle of elevation to the top and bottom of the aerial as 55 degrees and 51 degrees respectively. Calculate the height of the aerial. Again, it is best to draw this problem. So if you sketch it out, we know that a survey stood from the base of a tower on which an aerial stands, right? So we know both of them is on a level ground, so it's always best to draw a level ground. So let's say that this is our level ground here, right? And let's say that the tower, I'm going to just use straight lines and points to represent this. So let's say the survey is standing at this point, and we call that point A, right? Let's say that from here to this point up here, from here to this point, that's the tower, right? So this part here, this is the tower. So we know that this part here is the tower. And from here, going upwards to another point, that's where the aerial is. So this point is the aerial. Right? And let's call, so this is point A, let's call this point B, C, and D. Right? What else do we know? We know it has something to do with elevation, right? So all the lines are elevating from point A. So we know that it goes to the top and bottom of the aerial. So this would be the top of the aerial, this would be the bottom of the aerial. So we know that we need a line from the bottom of the aerial to where the survey is, and we need a line from the top of the aerial to where the survey is. That's it. We know that the angle of elevation is 55 degrees and 51 degrees respectively, right? So that means here would be the smaller angle, right? Smaller of both of them, which is the 51 degrees. And this would be the larger of both of them. So this has to be 55 degrees. So now it seems like we would have had almost all the information, right? This line here would be your horizontal ground, right? So now they want us to determine the height of the aerial, which is this height here. And this height is DC. So in other words, they want us to find BC. So they want us to determine the value of BC. What else do we know? A survey stood 100 meters from the base of the tower. So we know that the distance from point A to B, right, is 100 meters, right? So now we would have covered all our bases from this question. So how would you go about finding BC? It is clear that we could say that DC is equal to, which is this point, is equal to DB, which is equal to DB minus BC minus BC. So therefore, if the height of the aerial is BC and DC is equal to DB minus BC, it means that we need to find the height of BC and also the height of BD. So let's just go ahead and find out. So if we are considering the triangle ABC, that has to do with this 51 degrees here. So we know, considering triangle ABC, that has to do with this 51 degrees. So we know that this is tangent again, so we know that tan of 51 degrees is equal to the opposite length, which is where the tower is, which is just BC, right? So that's just BC over the adjacent length, which is 100. Again, I want to find BC, multiply both sides by 100, so BC is equal to 100 times tangent of 51 degrees, right? And you just put that on your calculator. So you know that 100 times tangent of 51 degrees is equal to approximately 123.5 meters. Correct to one decimal place, right? So that's BC there. So we know that this height here, this height, that's us 123.5 meter, right? Now we need to determine this DB, but DB associated with the triangle ABD, and that's where 55 degrees is. So considering triangle ABD, we know that tan 55 here, so we know that tan of 55 degrees is equal to the opposite length here, right? What's the opposite length? We don't know. So that's thus BD. That's what we want to find. BD or DB over the adjacent length, which is 100. Again, multiply both sides by 100. So BD is equal to 100 times tangent of 55 degrees. So we know if you put this on a calculator, we know that BD would equal to 142.8 meters, right? So now that we know BD and we know BC, we can now find DC. And remember that DC is the height of the earth. So we know that, therefore, DC is equal to BD, which is 142.8 meters, minus BC, which is 123.5 meters. So DC is equal to 8 minus 5, that's just 3. Keep our decimal place, right? So here, if you take 1 from this 4, this becomes 12. So 12 minus 3, that's just 9, right? And 3, then you'd have 3 left. So 3 minus 2, that's just 1. And 1 minus 1, that's just 0. So this is 19.3 meters. So therefore, the height of the area, which is this part, is 19.3 meters. Alright?